Question 1. During the process of commissioning a newly installed roofed HVAC unit, Mr. Fletcher observes that the system shuts down intermittently during peak load conditions. The manufacturer's specifications indicate proper airflow, refrigerant charge, and electrical setup. However, the digital thermostat appears to reset randomly when the system cycles. What should Mr. Fletcher investigate next? A. Incorrect duct sizing causing static pressure buildup. B. Voltage drop under load at the thermostat connection. C. Improper refrigerant superheat causing compressor overheating. D. Faulty expansion valve restricting refrigerant flow. Answer. Correct answer. B. Voltage drop under load at the thermostat connection. Explanation. Random resets in digital thermostats during cycling often point to voltage drops due to undersized wiring or poor connections, especially during high amp draw. According to NEC 210.19a, a manufacturer thermostat specs, low voltage devices are sensitive to voltage fluctuations. Unlike airflow or refrigerant issues, these would cause random thermostat resets but could affect system performance. Duct sizing and superheat should still be verified, but thermostat voltage is the primary cause here. Question 2. From the perspective of optimizing combustion efficiency, which of the following best describes the purpose of performing a flue gas analysis during furnace service? A. To verify refrigerant subcooling and efficiency levels. B. To determine airflow velocity through the heat exchanger. C. To assess combustion air mixture co-levels and burner performance. D. To confirm proper damper operation in the return duct. Answer. Correct answer. C. To assess combustion air mixture co-levels and burner performance. Explanation. Flue gas analysis measures OCO and sometimes NOx levels to evaluate combustion quality and safety. This aligns with ANSI Point 47 and NFPA 54, which require proper combustion tuning to minimize co-formation and maximize efficiency. It's unrelated to refrigerant charge or duct airflow. High COIN, incomplete combustion and potential hazards. Regular flue gas analysis ensures both performance and compliance with safety codes. Question 3. As demonstrated by a psychrometric analysis, a cooling coil drops the temperature of incoming air from 8 dB in 67 dB, 55 dB in 54 dB. What process is most accurately occurring across the coil? A. Only sensible heat removal. B. Only latent heat removal. C. Sensible and latent cooling with dehumidification. D. Sensible heat addition and latent cooling. Answer. Correct answer. C. Sensible and latent cooling with dehumidification. Explanation. A drop in both indicates both sensible temperature drop and latent moisture removal. Heat processes on the psychrometric chart moving diagonally down to the right implies dehumidification. ASHRAE Fundamentals Handbook confirms that wet blue or ROPS moisture is condensed from the air, which is key in human comfort and mold prevention. This is not a purely sensible process. Question 4. The contemporary view of large commercial buildings favor ERF systems over traditional split systems for energy optimization. Why? A. ERF systems operate only in heating mode and are more efficient. ERF systems offer simultaneous heating and cooling with variable capacity. C. ERF systems use water source geothermal inputs exclusively. D. ERF systems do not require indoor air handlers for zoning. Answer. Correct answer. B. ERF systems offer simultaneous heating and cooling with variable capacity. Explanation. ERF systems use variable speed compressors and electronic expansion valves, providing load-based modulation and zoning capabilities. ASHRAE Standard 90.1 promotes CRF use for energy efficiency. Their ability to provide heating and cooling simultaneously using heat recovery is a major advantage. They do require air handlers and do not rely solely on geothermal. Option B reflects the key design principle in ERF. Question 5. Given the circumstances, a technician finds that a three-phase condenser fan motor will not start, although voltage is present at the contactor output. Upon further testing, a phase is missing. What is the most likely root cause? A. High refrigerant pressure triggering safety cutoff. B. Failed run capacitor on a single-phase motor. C. Open winding inside the fan motor. D. Faulty disconnect or breaker on one line leg. Answer. Correct answer: D. Faulty disconnect or breaker on one line leg. Explanation: three-phase motors require all legs to start. A missing phase, single phasing, causes the motor not to start or to overheat. According to NEC Article 430, unbalanced voltages must be avoided to prevent motor damage. A faulty breaker or loose terminal is a common issue. A capacitor applies only to single-phase systems. Safety cutouts and water issues wouldn't cause missing phase externally. Question 6. Throughout the course of commissioning, a 3-ton R400 Tina split system is Daniels adds refrigerant until the sight glass is clear and suction line is sweating. However, the subcooling is only 4 degf when the system requires 10 degf. What should be our next step? A. Add more refrigerant to increase subcooling to manufacturer specs. B. Replace the TXV to control liquid flow more precisely. C. Reduce charge until suction pressure drops. D. Check airflow and indoor coil condition before adding charge. Answer. Correct answer: D. Check airflow and indoor coil condition before adding charge. Explanation: low subcooling can indicate undercharge, but poor indoor airflow, dirty filters, coil causes false readings. Per CAM Manual S and manufacturer guidelines, airflow must be verified before charging. Overcharging without addressing airflow can harm compressors. The T6V may compensate for load changes, but is not the primary control. Sight glasses are unreliable in R400 Tina systems. Question 7. With respect to duct system performance, why is duct leakage considered a major contributor to energy loss in residential HVAC systems? A. It only affects the noise levels and occupant comfort. B. Leaks increase refrigerant loss into the attic space. C. Condition air escapes on conditioned spaces, reducing system efficiency. D. Leaks cause oil to build up in duct corners. Answer. Correct answer: C. Condition air escapes on conditioned spaces, reducing system efficiency. Explanation: duct leakage in attics or crawl spaces leads to conditioned air loss and infiltration of unconditioned air, reducing efficiency. Energy Star and ASHRAE 152 cite duct leakages a significant source of waste. Refrigerant does not leak through ducts. Comfort, while impacted, is secondary to the energy and pressure implications. Question 8. In light of recent developments, Mr. Ahmed, an HVAC technician, replaces a defrost control board on a heat pump that was stuck in defrost mode. After replacement, the unit still enters defrost too frequently. What is the next best action? A. Replace the reversing valve solenoid. B. Check ambient and coil temperature sensors for accuracy. C. Adjust the indoor blower speed for better heat transfer. D. Bypass the defrost board manually to confirm operation. Answer. Correct answer: B. Check ambient and coil temperature sensors for accuracy. Explanation: defrost cycles are triggered based on sensor readings. If sensors give incorrect data, the board may misinterpret coil frost. Per OES specs and RE troubleshooting guidelines, verifying sensor resistance is critical. Reversing valve issues would affect heating cooling mode, not defrost frequency. Manual bypass doesn't fix sensor errors. Question 9. To better understand energy labeling, which of the following best defines the SEER rating for an air conditioning system? A. Average LUE per hour at full load. B. Ratio of total cooling output to energy input during typical season. C. Total ETU output per watt of instantaneous power. D. Maximum efficiency level achieved at startup. Answer. Correct answer: B. Ratio of total cooling output to energy input during typical season. Explanation: SEER seasonal energy efficiency ratio equals total cooling output BTUS over season total energy input alias regulated by DOE and RE standard 210-140. SEER represents seasonal efficiency under varying loads, not full load or instant performance. It helps consumers estimate operational cost. Question 10. Under the assumption that a contactor's coil receives correct voltage but does not pull in, what is the most probable issue? A. Contactor points are pitted. B. Coil has an internal open winding. C. Auxiliary contactors carbon buildup. D. Overload relay is tripped. Answer. Correct answer: B. Coil has an internal open winding. Explanation: A contactor coil that gets voltage but doesn't energize like it has an internal open NEC 430 and motor control circuit practices confirm that an open coil prevents magnetic actuation. Pitted points affect current flow after engagement. Auxiliary contact and overload trip affect continuity post pull-in, not coil movement. Question 11. To illustrate this point, a technician is troubleshooting a packaged unit that fails to start in cooling mode. Upon reviewing the ladder diagram, she finds that the cooling contactor is not engaging despite the thermostat calling for cooling. Voltage is present at R and Y, but nothing across the contactor coil. What should she check next? A. Low pressure switch between Y and the coil. B. Thermostat anticipator setting. C. Suction line temperature sensor assistance. D. Indoor blower relay for continuity. Answer. Correct answer. A. Low pressure switch between Y and the coil. Explanation. If R and Y are live but no voltage at the coil and open in the safety interlock path, like a low pressure switch is likely. Ladder diagrams show how safeties are wired in series to protect the compressor. Thermostat anticipator impacts. Staging, not safety. Blower relay and sensors wouldn't interrupt the cooling contactor's coil circuit. Per NEC 430, 72 and OEM wiring standards. This is the correct diagnosis path. Question 12. By evaluating airflow across an evaporator coil, its decline measures 0.5 total external static pressure and 400 CFM per ton requirement for proper latent heat removal. If the system is a 4-ton unit, what minimum total CFM should he expect? A. 1200 cm. B. 1000 CFM. C. 1600 cm. D. 800 cm. Answer. Correct answer. C. 1600 CFM. Explanation. Industry standards E.G. Manual D and ASHRAE fundamentals require 400 CFM per ton of cooling. For 4 tons, 4 cm ton equals 1600 CFM tex tons times 400 tex cm ton equals 1600 tex CFM. 4 ton cm ton equals 1600 CFM. Less airflow can reduce dehumidification, cause coil freeze. Static pressure is used with fan performance charts to estimate actual flow. Understanding airflow ensures correct heat transfer and coil performance. Question 13. In what ways can a faulty discharge air sensor in a valve system affect operation? A. Cause the valve box to overheat and trigger high limit shutoff. B. Prevent the blower motor from energizing. C. Lead to improper modulation of dampers and occupant discomfort. D. Create low suction pressure in the evaporator coil. Answer. Correct answer. C. Lead to improper modulation of dampers and occupant discomfort. Explanation. Discharge air sensors in valve systems per ASHRAE 90.1 and BAS logic help modulate dampers to maintain zone temperature. A faulty reading can result in incorrect air delivery, increasing energy use and reducing comfort. It does not directly trip safety limits or impact refrigerant pressure. Understanding sensor logic is key to diagnostics in smart systems. Question 14. Historically speaking, Mr. Delgado is maintaining a commercial hot water boiler. He observes short cycling during part load conditions. The boiler's aquastat is set properly and the circulator is operational. What component should he evaluate next? A. Pressure relief valve. B. High limit switch setting. C. Boiler staging or modulation control. D. Expansion tank charge pressure. Answer. Correct answer. C. Boiler staging or modulation control. Explanation. Short cycling during low demand is often caused by lack of modulation or improper staging, especially in multi-boiler or variable load setups. According to hydronic heating design standards, Hydronics Institute, staging must match load. The expansion tank and relief valve impact safety, not modulation. High limit doesn't affect partial loads unless it's setting correct, which was ruled out. Question 15. In response to a no-heat call, Lin reviews the wiring diagram of a gas furnace and finds the sequence W, pressure switch, limit switch, gas valve. If the system does not energize the gas valve and W has 24 voids, the most logical next test. A. Check continuity across the pressure switch during inducer operation. B. Jump R to Y to bypass cooling. C. Confirm amperage to the ignitor. D. Inspect outdoor sensor for open loop. Answer. Correct answer. A. Check continuity across the pressure switch during inducer operation. Explanation. If 24V is present at W but not reaching the gas valve, the technician must check the safety chain. The pressure switch must close to allow current through. Per NFPA 54 and OEM diagnostics, continuity should be verified with inducer running. Cooling circuits and outdoor sensors are irrelevant. Ignitor current comes after the energizers. Question 16. Among the various factors in duct sizing which most significantly affects friction loss in a system, A. Supply temperature, B. Static regain, C. Duct length and equivalent fittings, D. Ambient barometric pressure. Answer. Correct answer. C. Duct length and equivalent fittings. Explanation. Friction loss increases with longer duct runs and more elbows or fittings. Manual D calculations use equivalent lengths for fittings. Supply air temp affects thermal comfort, not pressure loss. Static regain applies in high velocity systems. Barometric pressure has negligible effect indoors. Proper layout minimizes friction loss and ensures fan efficiency. Question 17. Taking into account repeated trips of a scroll compressor on internal overload, is Fairchild measures correct supply voltage and amp draw at startup. The system trips after a few minutes, which is the most likely cause. A. Undersized suction accumulator. B. Overheated windings due to high compression ratio. C. Failing condenser fan motor winding. D. Defective crankcase heater wiring. Answer. Correct answer. B. Overheated windings due to high compression ratio. Explanation. High compression ratios strain compressor windings leading to overloads. Causes include dirty condenser, overcharge, or TSV issues. Copeland Application Engineering bulletins stress maintaining acceptable pressure differentials. The crankcase heater affects off-cycle liquid migration, not mid-run. Accumulators help liquid return, but don't prevent high stress. Fan motors would cause pressure to rise slowly, not immediately. Question 18. Across different scenarios when recovering R400 TINA into a dot-approved recovery cylinder, why must the technician weigh and monitor the cylinder's fill level carefully? A. R400 TINA must be stored in subatmospheric pressure conditions. B. Overfilled cylinders may rupture due to high pressure. C. Recovery tanks are rated only for R22 and not R400 TINA. D. The refrigerant must be vented before storage. Answer. Correct answer. B. Overfilled cylinders may rupture due to high pressure. Explanation. R400 TINA operates at high pressures. Cylinders must not exceed 80% fill by weight. Overfilling poses rupture risk, violating EPA 608 and DOT standards 49 CFRS. Entering refrigerant is illegal. R400 TINA requires high-pressure-rated tanks. Subatmospheric storage is not applicable for recovery. Weighing is essential to prevent hazardous overfill. Question 19. The fundamental question is, how does the principle of the second law of thermodynamics explain the operation of an HVAC cooling system? A. Heat can be created from nothing with sufficient pressure. B. Heat flows from cold to hot in controlled cycles. C. Heat must be removed using chemical reaction only. D. Heat naturally moves from high temperature regions to low temperature regions. Answer. Correct answer. D. Heat naturally moves from high temperature regions to low temperature regions. Explanation. The second law of thermodynamics governs that heat flows spontaneously from hot to cold. HVAC systems reverse this flow using work compressors per thermodynamic laws. No heat is created from nothing violates first law. Chemical reactions aren't necessary. Understanding these concepts is foundational to refrigeration cycles and energy analysis. Question 20. From a practical standpoint, what is the most important reason to perform regular inspection of condensate drains in a cooling system? A. To avoid fouling of refrigerant metering devices. B. To reduce pressure in the expansion valve. C. To prevent overflow, microbial growth, and water damage. D. To optimize defrost cycle timing. Answer. Correct answer. C. To prevent overflow, microbial growth, and water damage. Explanation. Condensate drain blockage leads to pan overflow, mold growth. Sealing damage and IAC issues. ASHRAE 62.1 and maintenance best practices require drain inspection and cleaning. It's unrelated to refrigerant flow or defrost cycles. This is a core preventive task with major health and property implications. Question 21. By comparing two rooftop package units during diagnostics, Mr. Bennett notices that Unit A frequently blows the control fuse while Unit B operates normally under similar load. Voltage readings at R and C show a 24V supply, but the fuse blows when the thermostat calls for cooling. What is the most likely issue? A. The thermostat is improperly set to heating mode. B. There is a short to ground in the Y circuit. C. The contactor coil has an open winding. D. The blower capacitor is undersized. Answer. Correct answer. B. There is a short to ground in the Y circuit. Explanation. A blown control fuse when Y is energized typically indicates a short to ground in the low voltage circuit. When the thermostat sends 24V to Y, if the wire is grounded or pinched, the fuse blows. NEC 240 and troubleshooting logic recommend isolating control wires and testing resistance to ground. An open coil wouldn't draw current, and modes don't blow fuses. Capacitors affect motor performance, not fuse protection. Question 22. Examining the consequences of poor grille placement in a long, narrow office space with a high ceiling, which outcome is most likely to occur? A. Enhanced throw leading to improved energy efficiency. B. Uneven air distribution causing hot and cold spots. C. Reduced latent capacity of the air conditioner. D. Condensate overflow from the primary drain pan. Answer. Correct answer. B. Uneven air distribution causing hot and cold spots. Explanation. Improper placement of diffusers and grills results in stratification and discomfort due to stagnant air pockets. Per ASHRAE 55, proper throw, spread, and placement are essential to ensure uniform mixing of conditioned air. It doesn't impact refrigerant cycle or condensate directly. Selecting the wrong grill type or location disrupts system performance, occupant satisfaction. Question 23. While it is true that all heat exchangers transfer energy, what distinguishes a condensing furnace's secondary heat exchanger from standard furnace? A. It increases the ignition temperature to reduce emissions. B. It uses steam injection to boost heat transfer. C. It recovers latent heat by condensing water vapor from flue gases. D. It reverses the direction of flue gas flow. Answer. Correct answer. C. It recovers latent heat by condensing water vapor from flue gases. Explanation. In condensing furnaces, the secondary heat exchanger extracts latent heat from flue gas condensation. This boosts efficiency above 90%, though efficiency ratings, if you account for this added performance. Standard furnaces vent hot flue gases, wasting latent heat. There's no ignition temp increase or steam injection involved. Direction irrelevant without heat reclaim. Question 24. The core principles of fan operation state that if a fan's speed is doubled, what happens to the static pressure it produces? A. It is halved. B. It remains the same. C. It doubles. D. It quadruples. Answer. Correct answer. D. It quadruples. Explanation. According to fan law number 2, static pressure equals fan speed 2. So doubling the fan speed results in fork static pressure. Fan laws help design efficient systems while avoiding motor overload. CF also increases with speed, fan law pound 1, while horsepower demand increases cubically. Understanding these principles is critical to avoiding duct damage or noise issues. Question 25. When analyzing electrical hazards, why is verifying a lockout-out LOTO procedure essential before beginning service on a commercial HVAC unit? A. It ensures proper filter sizing before startup. B. It eliminates excess refrigerant in the suction line. C. It prevents unexpected energizing of the system during service. D. It reduces compressor crankcase heater burnouts. Answer. Correct answer. C. It prevents unexpected energizing of the system during service. Explanation. LOTO procedures governed by OSHA 29 CFR 1910.147 are critical for preventing electrocution or injury from unexpected startup. Disconnects must be locked and tags applied. Filters and refrigerant levels are related. Crankcase heaters run independently and do not relate to LOTO. All service techs must comply with these safety protocols to ensure legal and physical protection. Question 26. A detailed analysis of a system reveals poor cooling performance despite clean coils, correct charge and functioning fans. The suction pressure is lower than expected and superheat is high. What is the next logical step in troubleshooting? A. Increase airflow across the evaporator coil. B. Replace the condenser fan motor. C. Check the metering device for restriction or blockage. D. Add more refrigerant. Answer. Correct answer. C. Check the metering device for restriction or blockage. Explanation. High superheat with low suction typically indicates restricted refrigerant flow, often due to a clogged TXV or filter dryer. Per ACAS troubleshooting guidelines, the metering device should be evaluated for dirt, moisture, or mechanical failure. Overcharging would worsen the issue. Airflow and fans affect coil temps but wouldn't cause the pressure-superheat imbalance seen here. Question 27. Throughout the course of performing a manual J load calculation, a technician notes that a room with west-facing windows requires more cooling than others. What is the most likely reason? A. The return air grill is oversized. B. Solar heat gain from afternoon sun is significant. C. The thermostat is too close to the register. D. The wall cavity is underpressurized. Answer. Correct answer. B. Solar heat gain from afternoon sun is significant. Explanation. Manual J factors include solar orientation. West-facing windows receive intense afternoon sun, increasing sensible heat gain. This requires larger cooling loads. Grill size and thermostat placement affect air distribution, not load. Underpressurization affects infiltration but is not the dominant factor in solar gain. Blinds, glazing, and shading can mitigate this. Question 20. The implications of poor sensor calibration in a BAS-integrated HVAC system can include which of the following? A. Elimination of manual override options. B. Precise temperature control despite equipment failure. C. Fault control strategies resulting in energy waste. D. Overcharge of refrigerant by automated system. Answer. Correct answer. C. Fault control strategies resulting in energy waste. Explanation. BAS systems depend on accurate sensor feedback for decisions. A miscalibrated temp or humidity sensor leads to false loads, causing equipment to overcycle and waste energy. According to ASHRAE Guideline 13, all inputs must be tested during commissioning. Manual overrides and refrigerant control are separate subsystems. Faulty sensors reduce efficiency. Question 29. The traditional approach to suction line sweating assumes that if the pipe is cold and sweating, the system is working properly. Why is this assumption potentially misleading? A. Sweating only occurs with overcharged systems. B. It may mask a restricted metering device with floodback. C. Only R22 systems are expected to sweat. D. Suction pressure and subcooling do not affect suction temperature. Answer. Correct answer. B. It may mask a restricted metering device with floodback. Explanation. A sweating suction line may falsely suggest normal operation, but if the TSB is restricted, refrigerant may pool in the evaporator and return cold liquid, causing compressor damage. Per Copeland Diagnostics and HVAC System Fundamentals, sweating is not the definitive diagnostic. Pressure, superheat, and subcooling must also be evaluated. Question 30. In a modern context of sustainable building design, what is the primary advantage of incorporating energy recovery ventilators (ERVs) into HVAC systems? A. They increase system tonnage for faster cooling. B. They eliminate the need for air filtration. C. They improve IAC by balancing ventilation and energy efficiency. D. They allow open windows without energy penalties. Answer. Correct answer. C. They improve IAC by balancing ventilation and energy efficiency. Explanation. ERVs exchange heat and moisture between incoming and outgoing air streams, providing fresh air without losing energy. Per ASHRAE 62.1 and LEED guidelines, this improves IAC and energy conservation, essential for green buildings. They don't increase tonnage or replace filtration. Open windows reduce ERV effectiveness, not enhance it.